Find the coordinates of the centroid of the area bounded by y equals x to the power 3, x equals 2, and the x-axis. So first we need to draw the graph, or a sketch of these functions here. So first I have the red one. It is the y2 equals x to the power of 3, and x equals 2 is this vertical line, and the x-axis is this horizontal line here, where actually y is equal to 0. So to find x bar, notice we need to use vertical elements here, dx, right? So each element dx is a distance x away from the y-axis. So we need to use our centroid formula, which is this: x bar equals integrate from a to b. Now our a starts from 0. We're going to x equals 2. We're integrating with this vertical element here, of x times y2 minus y1. Now that is the top function, which is y2 equals x3, and the bottom function, remember, is y1 equals 0 in this case. And we need to divide that by integral of a to b. Again, we're going from 0 to 2 of y2 minus y1 dx. Now it's very important to remember that we can't cancel things here. We actually had to find the integral of the top and the integral of the bottom before we could actually do any canceling. So if I plug these functions in, I have x times y2 is x to the power 3, so that goes in there. Take away 0 because y1 is 0, dx. And I have on the bottom integral from 0 to 2 of x to the power of 3, take away 0, where y1 is 0 again. So if we simplify the top here, x times x to the power of 3 is x to the power of 4, and then on the bottom we just have x to the power of 3. Now we integrate. So we don't actually drop our signs until we integrate. So now that we integrate, we drop this integral some elongated s shape, okay? So I've integrated x to the 4 is x to the 5 over 5, evaluated at from 0 and to 2, and on the bottom we have the integral of x to the power of 3 is x to the power of 4 divided by 4, which we integrate again at 0 and 2. Okay, so we plug these numbers in. 2 goes in first, and then 0, and we subtract according to the fundamental theorem of calculus. So on the top here we get, when we do this math, 2 to the power of 5 is 32 divided by 5, and divided by 2 to the power of 4 divided by 4, we get 32 over 5 divided by 16 over 4. Now if you're not wondering where the 8 over 5 comes from, let's take a look over here. So we get 32 divided by 5. Now that is divided by 16 over 4. So remember, according to our fraction rule, that means we actually need to multiply by the reciprocal, so we're actually multiplying by 4 over 16. And 32, we can reduce this. 32 over 16 is 2. So really we get, leaves us with a 2. This cancels. So we get 2 times 4, and that's where we get our 8 over 5 from. Okay? So that is the x bar part. That is the centroid in the x direction. But in order to find the coordinates of the centroid, we need to find y bar as well. So we do another sketch the graph again, then look at this in a different perspective. This time we're not going top function to bottom function, notice. It's left to right, where we have to subtract the left from the right. So our function this time is not y2 equals x to the power of 3. You solve, rearrange that for x, and x equals the third power of y. And x2 is still the vertical line, x equals 2 here. This time though we're doing horizontal elements and with width dy, and they are a distance y from the x-axis. So when we look at y bar, we do y bar equals the integral of c to d. Those are our limits of integration from bottom c to top d of y x2 minus x1. That's our right function. Take away our left function this time, dy. And then we have the integral of c to d again, x2 minus x1 dy here. So our limits of integration, this time we go vertical, so it's from 0 to 8. So that's why the limits become 0 to 8 here. And we have y, and then we plug in our x2. Our x2 is stated as x2 equals 2, and our x1 is now the third root of y. So we plug that in. Then we multiply in the numerator here. So we get y times 2, that's 2y. Now y times third root of y. Now remember, this is actually the y to the 1 over 3. So when we do this, we get y times y to the 1 over 3. Now using our fractional exponent rules, this is the same as y to the 1. So we're adding those together, so we get y and 1 over 3. But we need to write this as an improper fraction, right? So 1 plus 1 over 3 is actually 4 over 3 when we change it to an improper fraction. Okay? So that's where the y to the 4 over 3 comes from. Then on the bottom we have 2 minus third root of y, which is y to the 1 over 3. And then we integrate in the last step here. So y squared integrated is, 2y integrated is 2y squared divided by 2. Notice we can cancel these 2's here. Notice the integral sign again, as before, is gone now because we've integrated, so we don't need that integral sign anymore. So we're evaluating it from 0 to 8. And notice the integral of this guy, though, y to the 4 over 3. Well, the integral rule says we need to add 1. So if I take 7 over 3 and I add 1, 4 over 3, and I add 1, then that's 1 and 1 over 3 plus 1, which is 2 and 1 over 3. That's 7 over 3. So you can check that out for yourself there. And the other part is, remember, we need to get all over 4 over 3 plus 1. Now that's 7 over 3, but that's in the bottom, so I flipped it, right? So it would have been y to the 7 over 3 divided by 7 over 3, but then I flip that to the top to become 3 over 7, and then y to the 7 over 3. So you can do that every time when you're dealing with the fractional exponents there. Alright, so when we find that integral here, right, we get some long expressions here on the top, right? We get y squared minus 3 over 7, y to the 7 over 3. Then we need to evaluate it at 8 and 0 and subtract the 2 here. So that's the next step. So 2's canceled, 8 goes in for y here, and 0's going for y. And on the bottom, we actually get the integral of 2 dy. We need to do this integral is 2y, and then the integral of y to the 1 over 3 is, remember, we need to add 1 all over the exponent plus 1, so that's 4 over 3 all over 4 over 3, which we can rearrange it as I've done here, similar to this as 3 over 4. So that's what I have in the bottom here. So plugging all this in, you can see there's a lot of fractions to do. Here we have what happens to evaluating something like 8 to the power 7 over 3. Well, think about what that means, right? You can rewrite that as a, let's see, 8 to the power of 7 over 3. Remember, that can be written as the third root of 8 raised to the power of 7. So that's 2 raised to the 7, which is 128. Okay. That's 128. Okay. Okay, so when we work all this math out, then we get 64 minus the 8 to the 7 over 3 came out to be 128 times 3, which is 384 divided by the 7. Then on the bottom we have the same thing, 2 times 8, 16, and 8 to the 4 over 3. That is, you need to do the third root of 8, which is 2, raised to the 4, which is 16, times 3 is 48, divided by 4 is 12. So we get 64. Then when we work this out, we get 64 over 7, and you can check this out by just doing common denominator of 7. So we need to multiply 7 times 64, all over 7, and then minus the 384 here, and we get 64 over 7 and 4 on the bottom, and we're dividing here, so we're taking 64 over 7, dividing by 4, so that means we multiply by 1 over 4, right? And if you do that, you'll see that the answer is 16 over 7.